Hey there, everybody. Paul with ProShop here. We are standing in front of a company called ADDMAN Advanced Metal, formerly Keselowski Advanced Manufacturing, or CAM, started by the famous NASCAR driver Brad Keselowski only 6 years ago. We are going to see how they use ProShop today in this incredible facility where they're doing metal additive printing and then finish machining of those parts. It is an incredibly sophisticated operation with orders of levels of magnitude more data and process control than the typical machine shop. We're going to learn a little bit how they've, since joining the ADDMAN group last year in 2024, they're now expanding the usage of ProShop into another facility in California and more in the future. So it's an incredibly exciting company to be a part of, to support as they build things for space, for defense, for our warfighter, for satellites. They're doing a lot of amazing things. Unfortunately, we can't see a lot of the parts themselves because they are all very secret and controlled, but you're going to get the gist of it. And let's go check it out without further ado. Scott, good to see you.
Hey, Paul. Welcome.
Thank you for having us at ADDMAN Advanced Metals.
Glad to have you here.
Yeah, I'm excited to see the place.
Let's show you a little bit about what we do.
Absolutely. So we're going to check out the conference room, which is a beautiful spot. And so it's worth noting that we can't show many of the parts you make, but these are samples, and some parts we can. So yeah, tell us what you guys specialize in.
That's an unfortunate reality of doing a lot of work in the commercial space and military aerospace world. Is a lot of the stuff we can't show. But some really cool samples about some of the parts that we make. This part is actually kind of a generic injector, very similar to something used in the space field. This is just something that we threw together design-wise so we can show it off. But it shows off some of the capabilities of really being able to create parts that have really complex internal channels.
Yeah.
Now, a machine shop
designed for additive,
exactly,
not just subtractive.
That's not something you can just do on a CNC machine.
Of course.
So all these are 3D printed using laser powder bed fusion. Laser powder bed fusion is a technology that starts with a thin layer of powder, uses a laser to solidify that powder, and then the whole part drops some small amount called the layer thickness. We spread another layer of powder on and lays that next layer. And one layer at a time, we create a solid part. That allows you to do all sorts of things like create parts with really complex internal channels that you can't even get to.
Right.
But we can...
With an end mill or a drill.
Exactly, but we can manufacture.
Yeah, and obviously not only internal channels, but just incredibly intricate geometries that, you can't machine. So you talked about the layers. Give us some example of what layer tolerances or layer thicknesses.
So a layer thickness can range anywhere from 20 to about 140 microns.
Oh, wow.
So very, very thin.
How's that in thou?
Oh.
For those of us.
That's a good question. That's
thinking in thou. It's well under a thou.
3 or 4 thou.
Yeah.
My conversion is rusty there. But there's, you're talking about very, very precise layering. Even at 140, even at the thickest layer that we do, you wouldn't see any kind of residual layer lines.
Right.
You know, when the laser comes in, it actually welds down through 1 or 2, or in a small layer, 5 or 6 layers.
Oh, wow.
So you're constantly kind of re-welding and re-solidifying that material. And the settings that you do that with are the key to this technology. You know, there's a couple of machine makers that we've had great success working with, but getting those parameters right, getting those settings right, the thickness of the laser, the strength of the laser, the hatch spacing, all those parameters is really the key to this. And what the technology has done is allow us to 3D print parts in conventional and exotic metals, everything from aluminum all the way to titaniums and Inconels, things like that. And but also with the you know, the properties of having a good surface finish, of having dimensional accuracy, and we can do it quickly. So there's not a requirement to wait years for a casting tool to make complex parts.
Yeah, I was at a conference recently with with Blue Forge Alliance, and they were talking about just the incredible need to shorten lead times for parts that go on submarines and ships and other places. And it sounds like you guys are working on those things.
Yeah, we really are.
So what's an example of a lead time that would be X and you're now making it
Well,
Y?
I mean, we make parts that are conventional for a military branch that's conventionally only done using castings, but those castings have long since been lost. The military might have made 10,000, 50,000 of them, whatever, and back in the 60s and 70s. The tools were never really kept track of, and now they need to service those parts. And they don't want to wait the years and pay the millions of dollars to make another casting tool.
Wow.
So the thing to do is to send us the drawings, and we're literally taking paper drawings, hand-done drawings. There's no model. There was
Really?
never a model,
Sure,
right?
sure.
And we are reverse engineering those parts and then 3D printing them.
Wow.
To save having to wait those years and to have that lead time.
And the alloys and the densities and the strengths are comparable to the rod or the
Comparable
cast?
to billets, they really are, yeah. And it really depends on the heat treatment you use. The basic heat treatment that we do on just about everything is a stress relief before it comes off the plate. But we offer all sorts of HIP, solution and age type cycles depending on the material to get to the material properties that the customer is looking for.
Okay. And then your specialty, of course, is finish machining those printed parts.
Yeah.
You probably rarely go printed straight to the customer. Do you finish machine
There
almost
are a lot
everything?
of companies that obviously that do a tremendous job of CNC machining, and there's several other companies that do additive printing. I think one of our strengths is that we are integrating those two together.
Yeah.
And you'll see that in everything from the layout of our engineering room all the way to our finished products. And here's a good example right here. This is a sample part that we manufactured, and this is the way it's printed.
Okay.
And what you'll see is there's threads in those holes.
Yep.
Those threads are actually 3D printed into the part.
The thread
Now,
themselves.
The thread themselves. Now, that thread isn't going to meet a final
Sure.
dimensional check against a thread gauge, right? But it's more than good enough to be used right here to bolt down to the fixture.
Okay, so you
So
just
we're
printed those
actually-
in for fixturing
We're actually
purposes,
printing in our fixturing
and you'll
support,
cut that out later.
right? And then we cut it out, and then what the customer ordered, and of course this is a part that we designed as a demonstrator, but what the final design is that bore right there. So we come
okay.
in and machine out the thread
Yeah.
and
Brilliant.
make the finished bore. So in the final product, you don't see that support, but this is the printed level, and this is the strength of having the part all the way through the process. A lot of companies, buyers complain a lot about having to deal with one company to do this and then another company to machine the part.
Right.
Because when the machining company makes a scrap part, now you've got to go back to the company that makes
course,
this,
and they're
order
pointing
another
fingers
one.
at each other, and
This
it's
guy
just-
wants to complain that this guy didn't give him fixturing. This guy says, well, you didn't tell me, right? We do all this at once. Our manufacturing review actually consists of taking our additive engineers and the subtractive engineers, the people who are assigned to that program, and working together to develop the part all the way through the subtractive finish of the part before we ever print the first part.
Got it.
And if we do scrap a part, and everybody scraps parts sometimes, when we do scrap a part, we can have another one printing within 24 hours often.
Right.
So we take responsibility for delivering the final end part, and if that means printing an extra part, we'll print an extra part.
Love it. So let's do a ProShop cut here. So Scott, how has ProShop been instrumental in managing the process of all this printing and machining and everything, testing and quality?
You know, we did a lot of work with our implementation team, and we had a lot of discussions. And obviously, before we signed up for ProShop, we challenged you guys pretty hard because ProShop obviously was never designed to make additive parts.
Yeah.
So what we found is the flexibility that was inherent in ProShop allowed us to add all of the features and control all the parameters that we needed to control. In additive manufacturing, there is several orders of magnitude more things to monitor and track than there are in a CNC part.
Sure.
Things as simple as when this comes off a printer, and it may print 4 parts at a time, I need to be able to control the serial number of this part right from birth. It's not like a CNC part where we're going to make 100 parts, and at the very end, we're going to name them 1 through 95 and take the 5 pieces of scrap and throw them away.
Yep.
I need to be able to track this all the way back to the build plate and to its location. So, can we take that inherent flexibility that's in ProShop and expand it to give us traceability right from the first moment? Or can we control all the parameters that we're talking about, laser strength, hatch spacing, all these locked parameters, and can I control them in ProShop? And without that, we couldn't survive. But now we're to a point where we can bring companies in who are concerned about our ability to control these parameters, and we show them ProShop and we show them how we control those parameters, and the audits just kind of take care of themselves. It's pretty amazing because the customer sees that we can control that and we can monitor that, and it's reliable, and we can control who has access to what. It's really terrific.
And you guys had a pretty big win last year with, I think it was the Navy and some primes.
Yes.
And Jim presented at IMTS about it. We got an article about it. Can you just summarize a little bit of what that was about?
Yeah, I mean, they came in, concerned about our ability to control these parameters. We walked them through our system and our QMS here, which is largely based on what ProShop has to offer. And they basically came away with the fact that not only were we approved to make R&D parts, but they wanted to start pushing production parts on us, which is a whole nother QMS level for them. And they wanted to start pushing that stuff on us right away and get us working in that direction. Yeah, it's a consistent message from them. It comes down to us implementing all that stuff. We have to be garbage in, garbage out. We have to be really, really good. And it goes down to everyone on the floor. We need to create a culture where all that information is tracked and everyone understands the value of putting that information in. And when you do that, all of a sudden, the whole system just comes together beautifully. When we do audits, we'll walk the auditor out to the floor, and the auditor will walk up to somebody and say, how do you know what you're working on? And I can say, well, here's my work order. Well, how do you know what you need to do? And they open the operation, and they open the written description. Well, how do you know how to do that? And he clicks on right in the written description, there's a link to the task. And how do you know you're trained to do that? Well, the task links you straight to the training module. And when they see that flow, that all auditors want to challenge. Every auditor wants to ask the same questions, and you can flow them just from module to module to module without having to take them and go, let's walk over to this computer system, and this, our training computer systems, or our written description system is over here, and we don't do that. It's all in one place.
Yeah.
And when they can get to that right from the machine, it's a win.
Yeah, in Jim's presentation that he gave, he said that one of the auditors who'd been auditing for years said this was one of the best audits he'd ever been a part of.
Yeah, we had an auditor from a very large company shortly after reach out to me privately and say, I have a friend who owns a shop, and I was so impressed with ProShop. And this is someone from a major aerospace company, a lead auditor from a major aerospace company. Say that system was so good, I have a friend starting a machine shop, I want to get him on that system. Can you point me in the right direction and put me in contact with ProShop? That's the kind of impressions it's leaving, and it's
amazing.
It makes some of those audits it takes a whole lot of stress out of them. It really does.
Well, I'm so glad to hear that. I'm glad we can help. Well, let's go see more of the shop here.
Sounds
see more
good.
of the facility. This facility is so spotless and beautiful. I'm sure it comes from Brad and this NASCAR days and the expectations.
Brad absolutely loved and valued the concept of somewhere you can eat off the floors. That was just, to him, it was a sign of professionalism.
Yeah.
It was a sign of knowing what you were doing. It was a sign of caring about where you worked. And he really valued that.
Yeah, I can see that. All right, so we are standing in front of, what, about 10 machines? What do we have here?
Yeah, so there's
Tell
10
us about these.
EOS M280s in here.
Okay.
The EOS M280 is kind of a workhorse for us. It's considered a small frame machine. It's about 10 inches by 10 inches by 10 inches. We're using them in all kinds of materials. We use them in titaniums, Inconels, aluminums. Right now, almost every machine in here is in an M300 Meraging steel for a specific project we have going on.
Okay.
But that's just coincidence. We can change them. We have a very well-written procedure to change these machines over from one powder type to another. It's all captured in ProShop for us. We can change a machine in about a day.
Yeah. Okay.
Depends on what we're changing from and what we're changing to.
Sure.
But right now it's a large-scale production run,
What's large-scale production for
well,
you guys?
you know, 4 years ago we were making 2s and 5s and 10s of things. This customer came to us about a year ago and ordered 40 of this small part. I can't really say much more.
Yep.
Recently they came back to us and they were so happy with them they ordered 19,000 of them.
19,000.
With the intention to double that in the next few months and continuing orders beyond that. So all of a sudden we've had to take a quality system and a production system that was designed to make 10 and 20 and 40 parts and make 19,000. So it's one of the biggest growth opportunities we've had internally is to take all of our systems and scale them up, but control them while we scale them. It's not enough to just scale up a procedure. We started finding that we had lots of places in our procedures where we counted on one person going and talking to another person to communicate information.
Sure.
As soon as you scale, that doesn't really work anymore.
Yeah.
So there's a tremendous amount of learning, and some of it was rather painful learning. But we got a tremendous amount out of it, and I think we've really positioned ourselves in a great place right now. These kind of production orders now, and I say now, just in the last couple months, are much more comfortable for us. We understand how to do it. We understand that our procedures are ready to handle that.
Okay. So I imagine, for those not as familiar with additive, which includes myself, so if you do a 10 by 10 cube here, and you're doing small parts, you can do many at a time. Do you do multiple layers of the same part?
We can. We do sometimes, but in most cases it's easier to just make one layer of a part. But in this case, it's a small part, maybe about the size of my hand. We actually stand it up and we make rows of these parts. So there's about 50 parts on a plate.
50, okay.
Along with what's called some tensile bars. And tensile bars basically are a material coupon. It's a cylinder. We machine it down, neck it down, and then we pull it on a calibrated tensile tester. Yep. So we get an ultimate tensile strength and a yield strength and an elongation. So that's our evidence to the customer. That's our first level evidence to the customer of the material properties. And then we have a whole laundry list of additional tests we can do both here and at local NADCAP certified labs.
Okay. And then how long would a machine typically run, for example, with 50 of these parts?
These machines, these prints take about 3 days, just under 3 days. We like to keep them under an increment of days, just under, and that gives us the ability to flip the machine and keep the machine running. So for instance, a print that's 3 days and 2 hours might as well be 4 days at that point.
Right,
but if I can keep it just under 3 days, so we actually removed some parts. We actually originally had this plate with 55 parts on it.
Got it.
We found that by pulling it back to 50, we could comfortably do it in about 2 days and 21 hours. Gives us a 3-hour flip window, and now we can continue running them every 3 days.
Yeah, all weekend long possibly.
And be a lot more efficient that way. Yeah.
Cool. And I just want to focus on this thing over here. Maybe we can get a shot. So this is part of the process for swapping over. Can you just describe what you use this fancy vacuum for?
The wet dry. Basically, what it does is it allows us to clean the machine out. Once we're using this machine, anything we pick up is trash, is garbage. This is not recycling the powder. This is after the recyclable powder has been removed. We use this to actually clean out the internals of the machine. And it literally takes the air through a liquid to pull out all that powder, keep it safe, because some of these powders can have negative side effects when they're in just the right density. But it also basically just allows us to safely recycle material. And I say by recycle, I don't mean reuse, but recycle. Okay.
And then with a ProShop shot here, tell us you have VAC 395 on this machine. Tell us what you're doing with ProShop.
Yeah, that's our equipment. That's our equipment number in ProShop. So if we went into ProShop and typed in VAC 395, what you would see is its maintenance schedule, the instruction manual, the day it was acquired, basically all the information about this machine that we need. And ProShop will automatically notify us when this machine is due for service next.
I love it.
The machines are the same way. Each of these machines will have an entry in ProShop. these machines have daily, weekly, monthly, semi-annual, and annual maintenance schedules. They have 5 different maintenance schedules. Well, you can imagine those 5 maintenance schedules times 28 machines would be a nightmare to kind of keep track of.
Sure.
One of our steps on our work order in ProShop is to confirm that that machine is in calibration, right? So that means before they hit print, they'll really quickly click on the PL05 in the work order. It takes you to the equipment module. Everything is green. You go back to the work order and you get back to work. It takes about 10 seconds. But that will immediately tell you, is your daily, weekly, monthly, semi-annual, and annual all up to snuff? And if it's not, you see yellow, you stop, you put in a work order to get that job done, and then you go right back to running the machine.
I love it. That's amazing. What a great use of the tool. All right, this is kind of like the don't knock on the windows for the...
Yeah.
But yeah, tell us about these guys in here.
So our engineering layout, I think, captures exactly the way we run parts. And what I mean by that is we have 4 sections here, and each of them is a critical part of what we do. But it's laid out in such a way that they're constantly communicating. So our first layer is materials and processes. Then we have a section for our quality team. We have a section for our additive team, and a section for our subtractive team.
Okay.
Before we ever print a part, if it's going to be machined in here, then our subtractive engineer and the additive engineer who are working on it will meet together, review added stock, review part holding, and all of that gets done before we ever hit print for the first time. So by the time these guys have an opportunity to hit print, the subtractive team has already reviewed it. They already have a CNC path. They're already ready to machine it. The quality team has already bubble printed the drawing, has already reviewed the documentation, has signed off on that. Materials and process team has already reviewed everything. They'll create the work orders. They'll also confirm that we're using the powder specification is correct, and everything that the customer, every requirement that the customer has is going to get met.
Yeah, because you guys probably have a lot of flow downs.
Tremendous amount. Tremendous amount. It's dizzying at times.
Now I've heard you guys employ like PhD level, like material scientists.
We do. Right now we have 1 PhD on staff.
Okay.
At times we have 2. But yeah, absolutely. Having a good material scientist is critical for us.
Wow. Yeah, that's something most machine shops don't need.
Yeah.
And then I also see they have a bunch of cameras all showing what, you know,
exactly.
from these
Every one of these
machines.
machines has a small camera on it, and that allows the engineers in there to watch all their builds.
Yeah.
They can actually remote in right from home and watch their builds, because builds happen 24/7, and unfortunately so do build failures.
Right.
So that allows them to constantly monitor those builds, know exactly what's going on with each one. If it's a print they haven't made before, they'll pay really, really close attention to it. If it's something they've made 10 or 20 times, they have a lot more confidence in it. They don't need to pay quite as much of attention. But that allows them to monitor that as they work.
Okay, super cool. All right, next we have our QA lab we're about to go into here.
So I don't have to tell you, quality room is one of the most important places in a building like this.
Absolutely.
You know, without a good quality team, you're sending out a whole lot of garbage, and you'll never know it. Get into trouble really quick.
Yeah.
So, you know, got a great quality team, all sorts of resources here. We have an X-ray CT.
Yeah, that's a big X-ray room, or
Yeah.
Yeah. Very cool.
And obviously CMM machines, pretty much all the classic equipment, but all of it done to a level that's you know, that a really, really high precision machine shop would be familiar with.
Sure.
The challenge here is that we're not starting with blocks of billet. We're starting with 3D printed parts that don't have 2 parallel surfaces on them. So every fixture, every you know, the fixturing of these parts onto a CMM machine is really important. And we're often held accountable for those printed surfaces. So we do a lot of blue light scans. We do a lot of very high concentration CMM inspections.
Yeah.
Basically, we're having to control these parts in a lot of different ways. It's definitely a step above inspecting, you know, just classic billet parts.
Sure. So so you have 2 CMMs here plus the sort of the bigger arm for
the blue light.
Oh, that's a blue light.
Yep.
Okay. So you typically would scan that when it's straight off the printer to just
Yeah,
get a
we'll
point
actually
cloud?
scan it several times
Okay.
during the run. We'll scan it once right off the printer. And what we try to do there is you want to try to take a look at that part before you start putting too much value in it.
Sure.
You don't want to spend a lot of time machining a part that's inherently bad.
Yep.
And one thing about the laser powder bed fusion process is that you sometimes get thermal stresses and things moving around for thermal reasons. So especially the first time you print a part, sometimes that part will move a little bit more than you expected. We have simulations to predict that, but they're not always perfect. So sometimes you get a part that moves thermally in a way you didn't expect, and you have to reprint it to compensate for that. By you running that blue light really early in the process, we can capture that before we put additional work into it.
Yeah. That's fantastic. And I see we've got ProShop there up on the screen, so those quality checks are integrated right into the workflow and the work orders.
Yep. They'll run a blue light here. That file will get stored right in ProShop so that it's available later on. And all the dimensions, and now through a new feature, we're now allowed to actually document next to every single dimension the actual piece of equipment we use to measure that. So the caliper number, if these guys grab a caliper and they're going to measure something, they type in the caliper number, and the system stops them and says, wait a minute, that tool's out of calibration.
Right.
And won't even let them put in the number. Forces them to take that tool, put it in a hold cage, grab another one, type the new one in. Now that's calibrated. Now you can use that.
I love it. Sweet. And then just some optical measurements as well here.
Yep. Again, I think a lot of technology that people running machine shops would be familiar with, but definitely really important stuff. And ultimately, probably the most important is just visual inspection, right?
Sure.
We actually have to certify our inspectors to a pretty high level just to do visual inspections. But some of the specifications like AWS D20 for additive is very, very demanding on what those visual inspectors. And one of our steps on a ProShop work order is actually the engineer who ran the part to himself inspect that part.
Got it.
So the engineers inspect every print they do.
Super cool. Do you ever use pictures of what it should look like as like a go no go visual?
And that's we talked about going from kind of small volumes to big volumes. In small volumes, you can't really do that because every part you're making for the first time, and you're forced a lot of your steps. It's not just like inspection, but a lot of your steps have to be rather generic because you're giving a new part to a team and you're counting on their expertise to feedback on how you're going to execute that. As soon as you start getting into production, now you develop those processes much better. So now you look at our high volume work orders, and every step has pictures and descriptions and details, right, that have come from guys doing that step, right? They've found that you take that process and you're developing that process through the prototyping.
Yeah.
Now the other great thing though is at some point you lock that process, and we have the ability to lock down that process and say, okay, customer, here's the production order, here's production part number 1. And the customer has dictated that from part number 1 to part number 19,000, if we make a change, we need to report it to them.
Right.
So that allows us then to lock those down and say, no changes now. But through that early process, you're constantly taking pictures of, hey, watch for this, and watch for debris in this corner, and watch for this feature here, and to help those processes go smoother and be more consistent.
Right on. Where do you want to head next?
You
talk about that big
want to do a walkthrough of the big room?
Yeah, sure. Oh, it's a car guy.
When your company was originally started by a NASCAR driver and a championship-winning one at that, it's kind of hard not to have race cars here. We actually used to have quite a few more. A big collection of race-winning cars and show cars. Ultimately, Brad understood that space was better suited for machines, and that's what we've done. Kind of sad to see all those cars go because they were beautiful, but that wasn't the point of the building.
Machines.
We did keep these 2 show cars though. and they're pretty spectacular. But one of the coolest things about them is when we first started as a company, we were looking for case studies to do. We were looking for things that we could make an additive and make better.
I can see that shifter.
And that shift handle is the perfect example. And there's several other parts in here that you can see as well. So the shifter handle obviously is additively designed.
Oh, yeah,
the headrest support here is additive. The fire bottle mounts are additive. And you know, we didn't pretend that they were the perfect design at the time. What they were was proof of concept and proof of the ability to make parts that were lighter and stronger, right? We did do some work with designing them in really organic ways to show some of the features of powder bed, and that was the real strength of them.
So are Brad's actual cars have any printed parts like those in them?
They do. Several under the hood.
Several under the hood. Awesome. Super cool.
Even the steering column mount there.
Oh yeah, sure enough.
Was done.
Yeah. Super cool. So now we're going to go see your biggest machine.
Yeah.
Tell us about the travel and this thing.
So the Velo Sapphire XC is an 8 laser machine capable of making parts, I hope I get this right, 600 millimeters in diameter and 550 millimeters tall.
Wow.
The build plate alone, before you start making parts on it, weighs several hundred pounds, and only gets heavier from there as you start adding metal to it.
So you have to climb a good 4 feet just to even look in the window.
Just to get in. And the reason for that is this machine actually can be expanded to a 1 meter vertical height. So we actually had to lift this up to be prepared for that 1 meter expansion that wasn't available at the time we bought the machine, but will be soon. So it is quite a monster. It allows us to make huge parts, and that's one of the things that the space industry is clamoring for. Right. Rocket engines they're pushing the reusability of those rocket engines, and in order to reuse those rocket engines and not make them be, $100 million one-use things, the way to do that is through additive. And we're able to make parts that can stand the heat, can stand the conditions, much better than traditional manufacturing technologies. So the vast majority right now of rocket engines that are going to space are almost entirely the engine itself additive.
Right. Wow. Yeah. That really is just enabling this whole new evolution of space travel. Yeah, reusable space is what everybody's going for. And all of the major players are going at it slightly differently. But they all are doing the same thing, and that is you try to create a rocket that can go up, carry a satellite up, let go of it, and come back down so that a week later it can go up again. Yeah. Reusable space is absolutely the way everyone's going, and this is allowing it to happen. Do you anticipate needing to have bigger than meter prints in the future? How big?
I don't think the desire for bigger machines is ever going to end.
Okay.
I think it's really a limitation of the technology and the development of that technology. Right. This machine has 8 lasers in it. Unfortunately, that's 8 more things to go wrong. Sure. But it's also a vast improvement in speed and size and capability, and it requires control systems that are that much more complex. Sure. This machine has hundreds of sensors in it, and it's just far more complex than some of the smaller machines.
Yeah, wow. And I see, are you expecting more? I mean, there's a lot of open space here.
That's the hope.
Yeah.
Yep.
Awesome.
Yep, we're not going to let that space sit for long.
Yeah, so tell us about some of the growth you've had in the last couple of years. You've almost doubled the amount of machines, I think you said?
Yeah, I think we're 20, I think it's 25 machines in the building right now. I think we've skipped 3 numbers. So we'll go up to 28. I think we skipped 3, so that's 25 machines. I mean, we had 15 as recently as 2 years ago. Right. So, with more on order, and there's that constant need to add machines as customer requirements increase. And the production, the idea of production, which is something we've always wanted to get to, is now a reality. And that reality requires more people, more machines. We've hired some great people recently, and we're adding machines to maintain it. One of the biggest things I think you'll see if you were to look through our ProShop records is the utilization of those machines. As recently as 2 years ago, we might go home at the end of the night with 8 machines running overnight.
Sure.
Now with 25 machines, we go home with 25 machines running.
Right.
Every machine here is booked.
Right.
It's a great problem to have.
Yeah, you probably can't get machines fast enough.
It's a great problem to have.
Yeah.
Yep.
So let's talk about what this guy is working on right now.
So these are our SLMs, and what he's doing is he's preparing some powder kegs for installation on the machine. Basically, it's the way you put powder into them.
So he's obviously breathing filtered air because the powder is not good to breathe.
Yeah, when you're right up close to it, it's not the best thing for you. So
Okay.
yeah, he's using a full suit with positive ventilation. So that pack on his back is pulling air in, filtering it, and then blowing out. So it's a positive pressure system in the mask.
So, ProShop question, would you even have the masks in the equipment module with maintenance?
We probably should.
With filters or I don't know?
We don't, but we probably
Okay.
should.
Yeah, the list could almost go endless. Okay, so then he's mounting is he switching over between jobs or just more powder of the same type?
Adding powder.
Okay.
Yep. Yep.
So connecting that in.
Connecting that in, seals it,
sealing it with a
and then
clamp,
opens the valve.
then opens the valve and it drops down.
Yep.
And tell us about how these machines are different than the other ones that we saw.
The SLMs are a very similar size footprint to the EOS M280s. They're about 10 inches cubed. These are 2 laser machines, so they tend to be a little bit quicker. We've found they're happiest in aluminum, and these machines for us are aluminum exclusively. The most common aluminum we use by far is ALSI 10MG. We do a little 6061 Ram too, some others, but ALSI is 98% of our aluminum work. And these machines do it really well. We do a decent amount of aluminum work in our M400s as well. But these machines are always in aluminum. We do a lot of fixtures in these machines, and work like that.
Right. So tell me a little more of what it's like for the team here to support the defense industry, commercial space, just as an enabling technology for these things happening.
I think a lot of people take a lot of pride in that. You know, it's frustrating at times. Like, you know, I mean, I can't show on camera a lot of the things I'd love to show, a lot of the cool parts that we make.
Yeah.
At the same time, supporting the warfighter is I think a point of pride for everyone in this building. It definitely adds a lot of requirements. You know, when you're dealing with the aerospace world, for instance, the quality requirements are an order of magnitude higher than where you'll see in most other industries. So it makes you work. It makes you really pay attention to what you're doing. But at the same time, you know where it's going, and you know it's going to save lives, and we love that.
Yeah. Or going to outer space.
We're going to outer space.
Really cool
yes.
high-tech stuff.
You know, and the space industry is completely different to work with. The space industry is much younger, much newer, and they're also forced to move at a much, much higher pace. They iterate much, much, much faster. They tend to not have quite as much bureaucratic momentum to them, right?
Sure.
Some of these large aerospace companies have a tremendous amount of process that they've developed for very good reason. I mean, a tremendous amount of it protects them from a lot, right? The space industry almost doesn't have the flexibility to do that. Not flexibility, wrong word. They don't have the history to do that. And they're required to iterate so quickly that they move and they're willing to fail forward, but they just keep going and they just keep going and keep going. We'll get a PO for a part, and before we've even started manufacturing it, we have another revision. And
Sure.
I mean, it's like, but they're moving so quickly. it's honestly, it's a perfect application for additive because
Yeah.
we can handle
Adapt
those,
like that.
that revision control very well. So configuration management for us, change control is a big deal for us. Really making sure that we're always controlling that. Obviously, ProShop is a big part of that for us.
Yeah, I was going to say, having that paradigm in an environment where you have paper travelers and paper work instructions and paper QA sheets, it'd just be impossible.
And we used to have paper travelers all over the place. And I was the guy who had to, okay, we've printed 24 of these travelers. I have 24 batches of these parts, and I got to find all 24 of them. And some of them are out at plating, and some of them are at heat treating, and every one of them I got to cross off, and we're going to move this step in front of this step, so initial it and stamp it and all the. And now it's as easy as going into ProShop and changing the work order, and instantly it flows to the floor, and there's no question about it. So yeah, that change control is. We love being an all-digital company. I mean, you'll see very, very little paper on the floor, and what you see on the floor that's paper is typically just a tag.
For traceability.
It has color code and a tag with a work order number on it, and possibly a serial number if it's a serialized part, and that's it.
Super cool.
No need for any more.
All right. Where next? Should we? Oh, let's talk about the clean,
Sure.
the powder, depowdering. Yeah. So these don't look like printers. What are we looking at here?
They're definitely not. When you print a part in a bed of powder, you got to get that powder out.
Okay.
Now, if I was printing a simple solid block of material, that's very easy. The powder just kind of flows off it. But when you make parts with internal complex channels, you have to get the powder out of those channels. And that can be very, very tricky.
Yeah.
And it's really important to get that powder out before you send it off to stress relief or any kind of heat treat. Because if the powder's in there and you send it to any kind of heat treat, you're never getting it out. You now have solid material
Solid
in there.
chunks in there.
Yep. So what this machine does, it's basically a platform that can spin 360 degrees like this, can rotate up and down, and has vibration inducers on it, high frequency and low frequency thumpers on it, to shake that powder, free it up, and get it out of all the ports that we print on there. So basically, get the powder out. Hypercritical. And honestly, it's probably one of our customers' biggest concerns, and because they want us to prove that we can do that. So this, in conjunction with that X-ray machine, come together to become the capability and the evidence that we can get the powder out of your parts.
And it sounds like you used to do this manually before you bought these machines,
Very
which is okay
painful
for
process.
5 to 10.
Right.
But when you're talking 19,000,
A very painful process of holding the build plate up and tapping it and holding it
Yeah.
at different angles, and we had all kinds of little shakers and manual. This is absolutely the way to do it. So what this actually does is that captures the powder and we can recycle it.
okay.
So this machine is not only assigned to a material, it's assigned to a lot number of that material.
Okay.
So multiple machines might be running this lot number. It allows us to capture that powder, and we can sieve it and recycle it according to our internal procedures.
How many times can you recycle material?
Most materials have a quite long life. There's some exceptions. Some materials like titanium tend to pick up some oxygen over time and can eventually skirt out of what the standards allow.
Yep.
But a material like Inconel will run it until the lot will shrink itself to an unusably small quantity before we ever see any kind of chemical issues.
Super cool.
But we'll be testing it on a regular basis anyway, just to make sure.
Yeah, I imagine that powder management is quite a bit of complexity to that.
Super critical, super critical. And that's one of the things that customers want to see. With every print we make, they need a cert. So we actually use the ProShop system to track the lot numbers, create POs with attached cert paperwork. That cert paperwork flows straight to the customer in the form of an FAI package. So they always know exactly what they're getting.
Super cool. And you have quite a bit of powder storage, and like, man, can we go check out that part?
We do, yeah.
Let's go check
take
that
a walk.
part out.
Got to come in, sorry. Let's let him finish.
All right, so these machines, I don't know if you can tell on camera, but they're all vibrating and shaking at a high frequency.
Yeah, so these are powder sieves. So when you have that block of powder with a part inside it and you take all that powder out, any powder that's been cycled through the machine needs to be filtered before it can be reused.
Okay.
By filtered, the term we use is sieved. There's a very fine screen in there, and that screen is a very expensive mesh set to exactly the powder size, right? We want to allow the powder to get through.
But nothing.
But any semi-welded particulates, any large soot particulates, all those, we want to filter those out.
So if you have two pieces of powder that are bonded to each other, that won't go through the sieve.
They won't go through the sieve.
But only a single.
Right.
Wow.
So that's, you know, and the powder can have a range of particle sizes, but we choose that sieve screen to allow the powder through and not larger particles through. So every time that powder comes out of the machine, if it's been through the build chamber, it gets sieved. That sieve count gets tracked, added to the count for that particular powder, and we can always tell a customer exactly how many sieve cycles is on their powder. We've had customers that ask us to, you know, run a part with virgin powder, 0 sieve cycle, and then again at 5 and 10 to see material properties. And what we generally can show them is there's almost no property changes. That's one of those things that the industry as a whole is still working to really thoroughly understand.
Right.
But right now, you know, chemical properties are consistent, and we can show through chemical testing and particle size testing that we still have powder that meets the specification after 5, 10, even 20 sieve cycles.
Right. And I'm seeing a bunch of different alloys here. So how many different alloys do you guys print in?
15 or 20. I mean, we have our common probably 6 big hitters.
Yep.
ALSI, Inconel 625 and 718.
Yep.
Ti 64. Right now, Meraging steel is a big one for us.
That's the M300?
Yep.
Yep.
You know, it varies. We get customers who, you know, we get a big push for certain materials. You know, Haynes 282 for a little while was really popular. We had a lot of companies experimenting with that. So we kind of, you know, and a new material means that we develop a new parameter. We develop new capabilities for that, and we try to, you know, show the customer what we're capable of in that material, and then that becomes a capability that you know we have in the future.
Sure. And I'm seeing on these labels here, so this one weighs 100 kilograms, so that's 220 pounds.
220 pounds.
So you have these like custom little forklifty things that hold these containers.
Yeah, that's not something that you're just going to pick up and move.
No. And I imagine, of course, every single one of these is a lot, like you said, and then even the container within a lot, like if you have 4 containers of the same material, that's all tracked in the system.
And the lot itself, although it may get pulled for a machine to be run on a machine or something, the lot itself will have space in one of our storage rooms.
Yep.
So that will have an assigned location. So anything that is not either being sieved or is actively in a machine will be back in that storage location, and all that's tracked in ProShop.
And I love the fact that this used to be a NASCAR shop, and what used to be paint booths are now powder storage.
You use what you have,
Yeah.
right? So in this case, what we had was paint booths. And
these are very nice rooms.
The beauty of paint booths is they're safe, they're isolated, they're temperature and humidity controlled, and nicely lit and well organized.
Yeah.
So it's really the perfect place to control the raw material that is so important to this process. If you can't control the raw material, you will end up with garbage quickly.
Sure.
So controlling that powder is super, super important.
Yeah. And just tying back into ProShop, every one of these shelves has a number which goes into the ProShop inventory system.
The rack field is right here.
Yeah.
So this is P17, shelf 1.
Shelf 1, shelf 2, 3.
Yep.
Yep. And then distance from the left.
Yep.
So.
And depth if we need it.
And depth. Yeah.
Yep.
Yeah. Cool spot. So then you have one more room of printers, which we'll go take a peek, and then the machine shop.
Machine shop, yep.
I'm always excited to go into the machine shop.
Thank you. Thank you, bud.
2, 3, 4, 5. So another 5 or 6.
So this room is made up of 5 EOS M400s.
Okay.
Along with 2 other machines in the back, an EOS M290 and a GE M2. But primarily this is the start of our M400s. We have 3 more in the other room.
Got it.
The M400 is a 4 laser machine. It's 400 millimeters by 400 millimeters by 400 millimeters.
Yep.
So noticeably bigger than some of the other machines. Sure. It gives you a lot of capabilities. There's a lot of parts that nest really nicely 4 on a plate.
Yep.
So that gives you the opportunity, obviously, to increase your production.
Sure.
One of the tricks of this is maintaining traceability back to not just that plate, but also to the location of that part on that plate.
Right.
But that, the machines are incredibly capable. They're workhorses. They just run and run and run. They're great.
Nice. And so I think the machine shop's on the other side of this, right? But
yeah, but we got one other surprise here.
Yeah.
So when you run parts that take anywhere from a day to 10 days, 12 days.
Some of them take that long.
What you don't want is them to ever stop. Because even a 5-second pause will scrap the part in most cases.
Which could be tens of thousands of dollars.
Yeah. So what we have is a power grid around here that's notoriously unreliable. So we took it into our own hands. And this is a Vicon flywheel system that basically allows us to run the whole shop for on the order of 20 or 30 seconds. Just enough to damp out brownouts, to stop, short intermittent disconnections. When we looked back through our NCRs that we have for power loss, almost all of them were power losses of less than 5 seconds.
Really?
We get 1 a year that's a long-term one, and 98% of them are short-term ones.
And then you also have a generator that can come online for longer?
Well, we're set up for a generator,
okay,
but we haven't actually added that.
Sure.
Because this is 95% of the advantage at 50% of the cost. So we will add the generators later, but this allows us to buffer out all those short-term brownouts and short-term power blips. Because these machines are like canaries in the coal mine.
Yeah.
If the lights dim even a tick, the machine is shut off.
They're done.
It will stop.
And this will stop that from happening.
Well, that doesn't allow that to happen anymore. That keeps the power dead stable.
That is super cool. Yeah, that's not. I mean, it sucks when a CNC machine stops mid-cut. The spindle starts to wind down, but it's very likely your part's still good.
Right. You usually haven't scrapped a part. Here, you've almost always scrapped a part.
All right, we're in the machine shop, finally.
Yes, making chips.
Making chips.
So the challenging part of additive parts is that we want to machine them with the same accuracy as the best high-end billet parts. But you're starting with a part that, number one, doesn't have 2 parallel surfaces anywhere on it.
Yep.
And 2, has just a little bit of variability itself, right?
Yep.
A few thousandths, but just enough. And the key is fixturing the part.
Yeah.
Well, how do you fixture an additive part? Let me show you. So when you have a complex additive part with lots of curves, the best thing to do is use that same additive machine to print a negative of the part. And now you have an additive fixture that is perfect for holding that part. Drill a few holes for a rock lock pattern.
Index pins.
And you're good to go.
Right.
So that additive not only is doing the part itself, but is often also printing the fixture that's going to machine that part.
Cool.
It doesn't mean that indexing that part isn't a challenge.
Sure.
But it does allow us to have a whole lot better grip on that part.
But you probably have a work order for this, and you have to check this.
Absolutely.
Quality plan, everything, just like a part would.
All these fixtures will have a fixture number on them.
Yep.
You can go into ProShop and see where that fixture is being stored, what work order it's been used on, what parts it's been used on.
Yep. And some of them are printed right in, and some
Yep.
of them are laser marked.
Sometimes we print them in, sometimes we laser mark them in afterwards.
Yeah, super cool. Yeah, there's a lot of varieties of fixtures here. Again, all with the rack and shelf number and telling them where to go find them.
It's super important to us to be able to track these.
Yeah.
And keep an eye on when we use them, so if you pick up a fixture and say, I don't even remember what this is for, you go into the system and say, oh look, we haven't used this in 3 years. Maybe it's time to get rid of it.
Yeah. So we just went by the tool crib. You have, look, I mean, pretty nice tool crib.
Yeah,
balancing
we
and
keep
shrink
track
fit.
of all our tools in ProShop. So our tools are stored here in the tool crib. We do all our tool setup here. Tools are documented in ProShop, and each of those work orders will start with a job kitting step, which allows us to collect those tools, collect the fixtures, all the parts necessary to do that work order and execute that work order. So the machinist should get a cart with tools and a fixture ready to go.
And are the tools also, I see you got your Speroni presetter here, they're all preset and in a digital file
Yep.
that matches?
Yep.
Awesome. That's the way to do it. Keeps those spindles turning as much as possible and not touching off tools. So let's talk for a second about build plates. We haven't really talked about those too much, but at the bottom of every print, you have a plate of some alloy.
Yeah. So if it's an ALSI, we start with a 6061 plate. Most parts we start with a 1018 plate. But ultimately, all of those plates need to be refinished. So this plate right here behind you,
Oh yeah.
we just made a 300M Meridian steel print on. We need to cut that off.
So finish machine it off
Yep.
in this machine here.
Also, these plates tend to warp just a little bit, depending on the amount of heat you put in them. Not on a thick plate like this with a minimal part, but the bigger the part mass is relative to the thickness of the plate, the more chance that at the end of your build, your plate has a warp to it.
Yeah.
So very often it means surfacing both sides, maybe even re-drilling the 4 corner holes. But there's definitely a resurfacing aspect to keeping these machines running. And this machine just runs all day doing nothing but surface plates.
And how many times can you resurface and use that plate over?
I mean, you can see the difference in plates.
That one's like half an inch, that one is 2 inches.
Now, one of the things we have in ProShop is a field where the engineer can call out the allowed thickness of the plates for a given part. So the engineer might say, I know this part's going to have a lot of thermal constriction to it. I want a thick plate, right? And you might say, I only want plates between 1.5 and 2.25 inches. Or you can put in a field and say, you know what, this part is not going to stress the plate at all. It's thin. It's not going to have a whole lot of thermal stress to it. I don't mind plates all the way down to 3/4 of an inch.
Right.
So what these plates will do is they'll get measured and they'll get put back, and then the technician will pull a plate based on the engineer's instructions on what the range of plate thicknesses they can use, and then the operator actually measures it with a caliper, confirms the caliper is calibrated, measures the plate, documents the plate number and the thickness at the start of the build to confirm that it meets the requirement that was.
Yeah, that's a lot to keep track of.
Yep.
And then behind us in this tiny, cute little Mazak, that's where you machine your test coupons, right?
Yeah, yeah. Those coupons need to be turned before they can be pulled. They're turned to what's called an ASTM E8 standard. So they start like this: little density cube and 2 tensile bars.
And so these will be machined down, neck down. Then you'll put them in your. Oh, there you go.
And they get machined down to that.
Right. And of course, every one of these is tracked and serialized. Are they serialized or?
They're serialized back to the build that they were run on.
Okay.
And these stainless steel tags allow us to send these through heat treat without losing traceability to the job number.
Super cool. Yeah. Yeah, I can see how the number of parameters to track just magnifies so much. So Scott, tell us, you have a very fast-growing team here. How do you find, cultivate talent, and grow your team?
We definitely kind of interview aggressively, and we look really hard for talented people. I think we're pretty selective in our hiring process, but I think we also try to emphasize making sure that the team always has an aspect of youth to it, so that those people can grow up in the company. We love hiring from within, love taking people and giving them opportunities to find something that suits their talents better, allowing them to grow, inside the building.
Yeah.
I think it's ultimately, if you can take someone who's talented and driven and teach them how to do their job, then they end up being a more loyal and more functional, more productive employee.
Yeah, yeah. So we're here right in the heart of it. I see a bunch of Matsuras, a bunch of Mazaks, both turning and milling and horizontal.
Yep, definitely machines for all different aspects. The Matsuras are great for their multi-pallet pool capabilities. We can set up a lot of parts and jobs. It can be a variety of different jobs, and hit go before we leave for the night and let all those parts run and come back and have a bunch of good parts. So the operators, I think a lot of times people will walk through here and be surprised at how few of the spindles are spinning. But we really emphasize the fact that the guys should be spending their day setting up parts,
so
and the nighttime running them.
Yeah.
So it's really kind of a culture thing that we have to, kind of share with the guys, is make sure those spindles are running when they're not here.
And I see you guys have computer stations at every machine.
We do, yeah. Obviously,
really nice setups with the snap-on toolboxes.
Yeah, it was a simple, clean design, and it allows the guys to rely on their tools right from their work center. So they can be at their machine, they can immediately pull up a bubble print and see exactly what's going on.
Yeah, and work instructions, quality checks.
All of that.
All the above.
Yep. And every one of these tools will have a calibration sticker on it.
Yep.
Directly back to ProShop. That's how we control that. And we've gotten to the point now where we'll do a floor walk for out of calibration tools, and we can't find anything. And that's a pretty good feeling.
That's how you want it to be.
Yeah, it really is.
Yeah,
So
these Integrexes are beautiful.
Integrexes are monsters, right? I mean, they're just perfect for large parts, really complex parts. They just give us a lot of capability. Just a variety of machines to do all different things.
Yeah, I imagine for rockets and aerospace, you're doing a lot of round things that have lots of features coming from all over.
Perfect for the Integrexes, yep.
Yeah.
Yep, a lot of threaded ports, things like that.
And then a couple of horizontals here at the end.
Yep, horizontals we do for a lot of our plate production. We do some antenna components and some thermal transfer plates that run great on the horizontals.
Awesome. And one thing we didn't really focus on, but I know we have some B-roll, we'll show it, is cutting the plates off of the parts off the build plates. You're either doing that with wire EDM or a big bandsaw.
Almost exclusively EDM. Yeah,
okay.
we do some parts with saw, and there's special occasions where we even try to do saw no coolant if we're concerned about still having powder on the part somewhere. But EDM is by far the most common. It produces a much better quality cut. It's slow, it takes time.
But it's precise.
But it is precise.
Yeah.
Yep.
Well, Scott, this is such an amazing facility, and you guys
Glad
are
you
doing
enjoyed it.
such incredibly high-end work for critical applications and industries. Thank you so much for opening your doors and
Thanks
letting us
for coming.
see it.
Appreciate it.
Yeah.